In this video, we are going to cover the second part of conditional statements, which is lesson 4 in unit 2. Our learning goal today is we are going to use the law of contrapositives. So first we are going to review conditional statements. Remember, a conditional statement is an if-then statement. We can do 3 different things to that conditional statement. We can switch the hypothesis and the conclusion, and that's called the converse. We can negate the hypothesis and the conclusion. That means take the opposite of what the statement says. That's the inverse. Or we can switch and negate both the hypothesis and the conclusion, and that's called the contrapositive. Conditional statements can be written in symbolic form, which means we can use letters to represent each part of the statement. P generally refers to the hypothesis, and Q generally refers to the conclusion. In symbolic form, we can say if P, then Q, or P implies Q. That's what that arrow means, implies. Anytime that you're given a conditional statement that has a true hypothesis and a true conclusion, then that statement is considered to be true. A truth table is an organized way that we look at all the possible truth values of a conditional statement. T means true and F means false. So for example, for this, we're just going to talk a little bit about truth tables, and then we're going to do an example. This would be how you set up a truth table. So if we given this statement here, it says, if an animal is a whale, then it is a mammal. P is the hypothesis, an animal is a whale. Q is your conclusion, it is a mammal. So let's say that we know. If we know that the statement is that the hypothesis is true, okay, so an animal is a whale, and the conclusion is true, it's a mammal, then P implies Q would be true, right? So if it's both true, then we know that that's true. Now, what if our hypothesis is true? Okay, so it says if an animal is a whale, but what if our conclusion was false? So instead of saying it's a mammal, right, because we know that whales are mammals, right? They breathe air, they're warm-blooded creatures. But what if it said instead that if an animal is a whale, then it is an amphibian, right? Well, we know it's not an amphibian, right? That's false. So regardless then of the truth of the hypothesis, right, that a whale is an animal, our entire statement is now false because the conclusion was false, okay? Now, what if we start out with something that's false? If we start out with a statement that's false, okay, so let's say that we said if a person is a whale, right? We know that that can't be true. A person can't be a whale. Then it doesn't matter what comes next, regardless of whether the conclusion is true or false. The entire statement, I know it's surprising, but the entire statement is considered true. Okay, so because we don't have a truth at the beginning, it doesn't matter what comes after that. The whole statement is considered true. But really, we don't even need to worry about when your hypothesis is false. Really, the only two that we really need to worry about are these first two, when the hypothesis is true. Okay, so let's look at this one. Your conditional statements are always going to have the same truth values. So your table here is going to look the same. Even though our statement is different up here, the truth table is going to look the same. So here we said, we're saying if a figure has 3 sides, then it is a triangle. Okay, so here we said P implies Q. All right, so again, if we know that it's true, right, a figure has 3 sides, okay, that can be true, then it is a triangle. We know that that's true, so P implies Q can be true. But again, if that statement, if the conclusion was false, if it said if a figure has 3 sides, then it is a square, right? Now our whole statement is false, so that would be false. And again, if we start out with something false, then that's going to be true. But again, we don't really have to focus on those last two. So if we take the converse of the statement, that's when we switch the hypothesis and the conclusion. So now, instead of saying if P then Q, we're going to say if Q then P. So we're actually looking at Q first, and then we're looking at P. So here it's saying if a figure is a triangle, then it has 3 sides, okay? Now, if your conclusion is true, right, we're looking at that. So our conclusion is essentially becoming our hypothesis. So if we start with something true and end with something true, then it's still true, okay? So that's going to stay the same. But now let's look at this one. the next now, instead of starting with something true, we're starting with something false. Okay, so if we start with something false, remember what we talked about earlier, right? If we start with something false, then that statement is now going to be true. Okay, so the third one here, we start with something true, end with something false, and it's now going to be false. So the last one is start with something false, end with something false, it's now going to be true. Okay, so let's look at how they're different, all right? This is your conditional statement, right? We're just going to look at the P implies Q. So remember, for P being true and Q being true, we had true, okay? So that's the same. Now look at this next part, though. This next part is false, and this one's true, so that's different. This one's true, that one's false, that was different. True, true. Okay, so these tables are different, right? They're not exactly the same. So now let's look at the inverse of the statement. When we're looking at the inverse, we're saying that something is not, right? So we say if a figure does not have three sides, then it is not a triangle. This squiggly line here means that it negates it. It means not. So we would say not P implies not Q. All right, so here, if P and Q were true, right, that means that now the not P and not Q are both going to be false. Right? So the opposite of true is false. Okay? So the figure does not have three sides, then it's not a triangle. So remember we talked earlier about if we start with something false, right, then that statement is going to be true. All right? If we start with something false, that statement is going to be true. Here, if we start with something true and end with something false, then it's going to be false, and then true, true, true. Okay, so now we have true, true, false, true. So now let's compare the original. Now we're comparing the conditional, okay? Everything that we do is going to compare back to the conditional. Okay, so let's look at how these are the same or how they're different. Okay, so again, look, we have true here at the top. Okay, so that's the same. But now look, this one is false and this one is true. This one is true, this one is false, this one is true, this one is true. So that's how they're different. Okay, now let's look at the contrapositive. Remember, the contrapositive means that we switched the hypothesis and the conclusion and we negated it. So now we would say if a figure is not a triangle, then it does not have three sides. So now we're saying not Q, then not P. So Q first, then P. All right, so start with something false, now it's true. Okay, start with something true, ends with false, that means it's false. Start with something false, end with true, that means it's true. And then obviously if both are true, then it makes it true. So now let's look at these truth tables. Okay, true, true, false, false, true, 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 true. Okay, so these are exactly the same, right? Conditional and contrapositive. So that leads us to the law of contrapositives. We noticed in the previous slide that the last column of both of the truth tables were the same. That means whatever is true for one is true for the other, and vice versa. So if you're given a conditional statement that's true, you know that the contrapositive will also be true. So that means, right, a conditional statement and its contrapositive are functionally equivalent. If a conditional statement is true, then the contrapositive will always be true as well. This is also useful because if you know that the contrapositive of a statement, you can also assume that the conditional is true. So it works both ways. Okay, so now let's talk a little bit about practicing this, okay? So we're just going to talk this one. If you know that a statement is true, what do you know about the truth of its converse, inverse, and contrapositive? Okay, we'll go think back about what we know about about our truth tables, right? With converse and inverse, our truth tables were different, right? So the converse and inverse, we really know nothing, right? We don't really know anything about the truth or false about the converse and inverse, right? So we can just say that we don't know anything about those. Regardless of whether your conditional is true, sometimes your converse and inverse will be true, but sometimes they won't be. So we can't really say anything about that. Now, contrapositive though, right? What did we say about contrapositive? If the conditional statement is true, then the contrapositive is going to be true as well. Okay, and then it's going to always be true, and we can cite the law of contrapositives as our reasoning for that. So you don't have to go back and tell me all that. All you have to say is the law of contrapositives, right? Because we've already proved that a conditional statement is true, the contrapositive is also always true. So now we're going to write a conditional statement that's equivalent to the Euler diagram, and then we're going to determine whether the conditional statement is true or false. Okay, so remember, in a Euler diagram, we're starting with the little, and then we're going to get bigger. Okay, so this one says if we start with, excuse me. Okay, so here we can say if a triangle is an equilateral triangle, then it is an isosceles triangle. Okay, so now we have to know a little bit about what an equilateral and an isosceles triangle are to determine whether this conditional statement is true or false. Okay, so remember, an equilateral triangle means that a figure has 3 equal sides. Okay, an isosceles triangle means that it has 2 equal sides. Okay, so if a triangle is an equilateral triangle, right, if it has 3 sides that are equal, then it also can be an isosceles, because isosceles only has to have 2, right? So we can get smaller here. It has 3 equal sides. That means it also has 2 equal sides. Okay, so this statement is true. Okay, and then the last one here is we're going to draw a Euler diagram for the following statements. If 2 angles form a linear pair, then they are supplementary. Okay, so we're going to start with the little circle. Okay, so we have angles form linear pair. And then we have it's encompassing in the big circle, then they are supplementary angles. Okay, and we do know that that's true because a linear pair, okay, are 2 angles that add up to make a straight line, okay, and a straight line is 180 degrees, which means supplementary means it adds up to 180. So we know that angles that form a linear pair are also supplementary angles. And that is the end of Lesson 4, Unit 2.